right, well, happy Thursday. We are finishing up arrays and vectors. We had lots of fun doing two-dimensional vectors, my favorite here. We want to look a little bit more at iterating over vectors and some of the ways we can manipulate vectors. A little bit more practice with that, which is fun. Up until now, probably the only thing you've done is like add stuff to vectors. Just push back and push back and push back and push back, which is great. But now also we can take things out of vectors as well as we go, which is pretty cool. So we'll look at that. And then probably won't take the whole time today. I'll have a little bit of time to finish up whatever you're working on with Project Zero. Hopefully that's going well. And we got that one coming up. When does that one due? The 4th at 3:30. So the 4th is Tuesday at 3:30. So first thing we'll do in class is I'll go over my solution to the project. Right? So get it in, get it done. If something comes up, get it to me somehow. Right? I get GitHub doesn't, sometimes weird stuff happens, that's okay. But if you don't get it to me by 3:30 and I go over the solution at 3:30, I can't take it late. Like I had my just earlier class, someone came up after class, they're like, oh, I couldn't get it submitted, can you help me submit it? It's like, I just did the solution in front of everybody. I'm not accusing you of copying off of me, of course, but you know, it's not fair to everybody else that you might have done that. Is that okay? So I'm not a jerk, but just get it in. If GitHub doesn't work, just email it to me. I hate email, but that's fine. Like we've got a record of it. We'll get it working. Okay, it's not the end of the world, but get it in my hands by 3:30. Okay. So it's not fair to anybody to take things late after I've gone over solutions. So, all right, and that should be a lot of fun. Let's see. So let me fire up this our arrays and vectors chapter. Did anybody get through the lab and finish their Connect 4? Or is everyone behind a week now and like didn't actually get started on it? It happens one of these years. I might not let you turn in labs the week after, but it's not worth it right now. It's okay. It's not the end of the world. So similar to tic-tac-toe, but more loops. Right? More practice playing with two-dimensional vectors, rows and columns. That's sort of the exercise that we're doing here. How do we go from this one and look at 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 this one, right? When you look at your Connect 4 board, Connect 4 here, right? It's 7 by 6, right? Or 6 by 7. I forget the right. How do you determine here? There's a good one here, right? Yeah, 6 rows, 7 columns. So in order to see if you have 4 in a row, I'm going to look at some row, or I'm going to look at some column, and column plus 1, column plus 2, column plus 3. That's 4 in a row, right? You can only get that from the first couple rows or the first couple columns, right? So as I'm looping, I'm going to say for every row and then for every column between 0 and 4, right? Less than 4, right? It's a loop there. Then I can say, okay, starting at 0, does 0 plus 1, does 0 match 0 plus 1? Does 0 match 0 plus 2? Does 0 match 0 plus 3? If not, go to the next one. Okay, does 1 match 1 plus 1? Does 1 match 1 plus 2? Does 1 match 1 plus 3? I don't know. Okay, go to the next one. Does 2 match 2 plus 1, 2 plus 2, 2 plus 3? Right? Oh no, wait, 3. Does 3 match 3 plus 1, 3 plus 2, 3 plus 3? If we never go beyond 3, we'll never go out of bounds of our array or our vector, right? Because I know 3 plus 3 is 6. I have an index 6, right? So that's for checking by that, right? Same idea with checking for column matches, right? Okay, starting at row 0, row plus 1, row plus 2, row plus 3. But I can't go any further than the third row because there's no plus 3 after that, right? Same for the diagonals, right? But now we're just combining the two of them. So I only really have this box here of 12, right? This top left here. From there, I'm going to go down a row, down a column, down a row, down a column, down a row, down a column. I can't go lower than row 3, index 2, and I can't go further than column 3, index 3, right? Because there is no 4 there. So going diagonal down, and then same idea with going diagonal up. Now we're going to start at the bottom, right? Start at row index 5. Does it match -1, -2, -3? Right? If you go above row 3, you can't do more than 3 minus 3. Right? There's nothing beyond 0. So we're just limiting where we're ranging from when we look at these here. So lots of practice doing loops with loops with loops with loops. Right? So it's just a loop inside of a loop. Tic-tac-toe was a little bit easier. Right? We just had one loop. So it was a little simpler. So that's the idea with that one here for saying if you've got Connect 4 by row, Connect 4 by column, Connect 4 by diagonal up, Connect 4 by diagonal down. Okay? Break into the small pieces, tackle it here, see if that works for you. That make sense? All right, cool. And then dropping pieces, and that's probably the last one, right? All you need to know is the column, And then you just start at the bottom. Hey, is row index 5 open? Is the 6th row open? If it is, piece goes there. If it's not, go up one. If it's not, go up one. If it's not, go up one. If you get past 0 and you didn't put a piece in, you should raise an exception because it's no good, right? It's full. Or you could start checking, hey, is the row 0 at that column full? If it is, raise an exception. Either way works. Whichever you'd like to check for first, perfectly fine. Generally, we check for exceptions first, and then we do the normal stuff. But again, it's not really the end of the world to have to check all 6 rows. For our purposes, it's not going to make any difference to be 6 more operations. Right? It's connect 4. It's not like we're doing this a zillion times or anything like that. So, all right. So that's some thoughts for connect 4. Ideally, you get it done before the next lab, so when we start lab next Tuesday on new stuff, you can work on the new stuff. But again, I get it, life happens, whatever, we'll make it work here. All right, that all good? Okay, so looking at vectors then, let's go back to here. So we did our little tic-tac-toe game, we had some fun with vectors, let's do some other fun stuff with vectors here. We'll just leave tic-tac-toe for later. So we said, hey, I want a vector of type, I don't know, we can do a vector of string here, and we can do classes, right? And we can assign it right away. We don't have to push back if we know the initial values here. So what are some classes you folks are in here? So we're in CIS 200. What else?
CIS 306.
306? 306. Is that discrete?
Yeah.
Discrete 2?
Yeah.
Okay. And what else? What other classes? 275. 275? That's discrete 1, right? Yeah. Okay. What else? You're all probably in a math class, right? Or did you finish your calculus already?
I'm in ENT 400.
ENT?
Yeah.
400? I don't even know what that is.
That's entrepreneurial thinking.
Entrepreneur ENT. Okay, neat. Is that any fun?
Yeah.
Okay.
It's like a free class.
Okay. Yeah, sure. All right, so there's a couple of classes, right? You know, that's fine. We can go and add some in here. So if we wanted to, we could get a random class out of the list, right, by picking a random index, right? We can do random numbers. We like random numbers. So we say a int for random index. Index is, and we have rand, right? And then random gives us, what is this one? Is this the between 0 and 1? Or is this the one that's like any number? I can never remember. I think we have to do modulus, right? So modulus by what? Or is it multiply? My goodness, I don't even remember here. You guys are making me look here. Okay, we'll just check it. We'll just see out random. See what we get here. Because nobody else remembers off the top of their head. That's okay. We don't have to remember. All right. Well, it looks like a positive number. So we just modulus, right? Take it modulus by whatever we want here. So the most it should be is, well, we've got 1, 2, 3, 4, but there is no index 4. We don't want to get a 4, but mod 4 works out because we'll never get 4. We'll get 0, no remainder, remainder 1, remainder 2, remainder 3. We'll get any one of our valid indexes here, right? So we can say, hey, I want classes, oops, oh goodness, classes dot size. We can use this size function here. Oh, wait, let's actually store that here. So int random index is a random number modulus by the size of classes. How many items is in classes here? So I'm guaranteed to get a valid index, so I'm going to get between 0 and up to, but not including the size. And there is no index at size, right? Because we always start counting at 0 like all normal people do. You teach your kids 0, 1, 2, 3, 4, 5 when they start counting. People look at me funny when I do that to my kids. That's like I'm mean or something. All right, so we get a random index, and then we can just spit it out here. So hey, your class, random class today is, right, my classes, and then either the at notation, random index. Oh my goodness, where's my random index? There it is, here. Or we could use the square base notation. I'm partial to square base notation. I did double check. I found it in Zybooks here. They did tell me, which was nice here, the arrays versus vectors here. This one. C++ allows vectors to be accessed using the braces, but square braces, brackets, I guess brackets, okay. All right. Involve no range checking, but we tested it and it did crash on us. So I think it's optional depending on what version of C++. That's my best guess right now. Honestly, I don't recall. So At is probably best, but it seems like it works okay with this in modern C++, so I wouldn't sweat it too much. When you go get a job somewhere and they say just always use at, just smile and nod. Okay, I'll just always use at, no biggie. It's not any harder, right? It's just different syntax. So add an index, spit it out, so we can get that, right? What if we wanted to like remove something from our list here? Can we remove an item? Yeah, we can. So we can take our classes and we can pop back. So pop back removes the last item. Now, it's not removing an item at a specific index, it's only removing the last one, but like push back only adds to the back, right? We can take off the last one here, get rid of it, and then when we run this again, we won't have that item. We don't even need to call it an int. So now we'll pick a different random number, but because it's based off the size and we've removed something from it here, it's going to work. Right, so we'll get two classes here. Yeah?
Can you pop out at a certain index?
There are ways to do it, but it's a small pain. We'll get to that in a second. Yeah, removing at a given index here. And honestly, I'll just go ask the chatbot because I don't recall off the top of my head. But we'll do it. It'll be a good demo. So this is going to be nice and flexible. And now instead of just having some sort of fixed list where I had to ask you folks, we can let the user build a list here. Like, okay, so some string for class, I don't know, input is blank to start, and while input does not equal, I don't know, I like using like quit or something here. We got lots of options here. If it starts a blank, it doesn't equal quit, so we're going to start. So we'll see out enter class or quit here, and line, and then we'll see in our input. And then now we have to kind of double check this, which is a little bit obnoxious, but otherwise you have to do the prompt outside again. Some people like prompting outside. I like only prompting once. It's okay. If my input does not equal quit, then I'll take my classes and I'll push back the input. Right? So for as many classes as you want, until you type in quit, I'm just going to keep adding into your list. We can go through the whole catalog if we want to, right? If you're terribly bored here. I don't know. I found it a little odd that they encourage you to take more than 12 credits by giving them to you for free, which sounds really cool on the surface. But then I get people who like take 18 credits and they basically always drop or fail one of those classes because 18 is a lot of work. I guess if you're in the freebie class, you don't have to do a lot of work for it here, but generally classes should be a decent amount of work, right? But somehow it works out well, but then if you have a life outside of school and you can't take more classes because you don't want to fail one of your classes, then you only take 12, and the whole system's a little bit screwy. I think the premise was good, right? Encourage people to take classes and pass, but the implementation kind of falls a little awkward on that. So, but yeah, hey, I've got 6 classes this semester. Good luck. Hope you don't have a life. But sure, enter them all in here. We can pick a random one based on size. This is why vectors are super nice and flexible here, right? Because we can get the size out. We don't have to do any sort of tracking. We could do a dynamic array based in memory and ask them, hey, how many classes do you have? And then go size it at that amount if we wanted to. Sure, that's also a lot of work, right? It's just a little easier to just push back every time we want here. It goes relatively quickly for us here. So we'll get a random class, figure out a random class, we'll remove one here. So, oh, you probably dropped one, and then we'll go drop that one here. So enter some classes. We got 200. Oh, CIN's going to break if I have spaces here, isn't it? I'm going to pretend I did the get line instead of CIN's so we could do spaces, but we just won't here. So 275 and CIS 307. I forget what your numbers were here. ENT 400. I thought there was like an engineering class that was like a freebie, but that's okay. And then quit. And hey, we picked a random class. We got rid of one. We picked another random class. Seems to work okay so far, right? We can close that. Oh, I crashed it by closing it. My bad. Right? So it's only so good though, because ideally you want to like pick a specific class to drop, not I'm just going to take the last one you registered for and get rid of that for you. It might work okay, but in general, I think you'd be a little upset if the system did that for you. So let's see how we can remove a specific one. And before we get to that, we got to look at one more thing here. We have to look at iterating over a vector. So to print them all out here, right? We could say, for string class, or I don't know, course, because the word class is reserved. I can't use that, right? It shows up blue, and then it yells at us here. In classes here, right? You can see out the course, and an end line. So this is our basic enhanced for loop. For every one of these items, give me something here. Right? We could also loop through by index for int index is 0, index semicolon, index is less than classes.size, index plus plus, and then see out the course's classes at the index here. Right? Now, this one is good for read only. This one is great if we want to modify, right? Because you can't modify course and have it be modified in your array here, but you can modify the thing stored at this index and have it be modified, right? Slight differences here, right? So this is essentially read only until we get to classes. Well, if you put an array of classes or a vector of classes, then you can interact with it, but you can't like wholesale replace it. It gets a little bit awkward here, but we'll get there eventually. And this is, can modify what's stored at the given index. Here, does that all make sense? The next way we get to go about it here is using something known as an iterator. And using the iterator, we can start messing with our vectors in place. So an iterator is a little bit awkward, but it's okay. So let me just Google again here. Iterator. I don't remember the syntax here. It's not worth keeping in your head. I love like this just takes so long and it costs them money every time they do this. But like on every query now they're doing it. Versus like I'm just going to go to Stack Overflow because it's faster. So it's a type of vector : iterator. So it's the scope, vector of string scoped iterator here that I can work with. So I know my vector is a vector of strings, right? So I'm going to say, hey, my vector of type string : iterator here. So this is the iterator object here. This looks really awkward and crazy, but that's okay. And we'll just call this the it. Sure, why not? It. And then we can assign it my classes dot beginning is the beginning location here. Notice it's a iterator here. Looks a little weird, but that's okay. So begin, I believe that's a function call. Okay. So we start at the beginning. And then I can loop through, I can say for, usually we put that in here, I guess, right? So let's do it this way. So let's put it in my for loop here. So my iterator starts at the beginning here, while my iterator is not equal to my classes.end. As long as it's not the end here, I want to take my iterator, I think it's plus plus. That sounds right. So you can sort of think of an iterator as like a pointer. We dealt with pointers when we made dynamic arrays. I said, hey, here's a pointer, which really was just, here's where it starts in memory. And then I could add 1 to the pointer to get the next thing. I could add 2 to the pointer to get 2 more things. I could add 3 to the pointer to get 3 more things. The iterator is essentially the same thing here. It's pointing at a specific location in our vector. So, and the end is the specific ending point, which is beyond the last item, which is super cool. So eventually you get to the end, which is you've read everything, right? So it's set like you don't have to go as long as you're less than or equal to the end. Like you just go until you're not the end. Until you're not the end. Iterator plus plus. Awesome. We can go through and print things out here. So then to go get the particular item, though, it's a little bit weird. We dereference it. This is essentially a pointer, right? So we're saying, hey, what does that thing point at here? So then we see out the dereferenced iterator and an end line here. So we should get our list of classes, our list of classes, our list of classes. And then we'll go and do this in a second here. So we should get 3 in a row, right? The read-only version, the by index version, and then the iterator version here as we go. Let's give it a try. So CIS 200, CIS 275, CIS 305, whatever here. And we'll just quit. We don't need a ton of them here. So we get the 3, we get the 3 again, we get the 3 again, we get a random one, we get a random one. Life is good so far, right? It seems to work, okay? So it's a pointer, right? The iterator is a pointer, but it's a pointer using vectors, which is fun. So now we're combining the two here, so we can have a pointer for our vector. Gets to be a little bit awkward, but that's okay. And then if you don't like typing, which nobody likes typing, right? We want to be lazy here. The other thing you can do, let me just comment that whole thing out here for a second, and copy that, is have you seen the auto keyword before? In C++, did anyone show you that? You can say, hey, this is auto, which is saying, hey, please automatically assign the type based on whatever's on the right-hand side. Excuse me. If the thing on the right-hand side is a vector of type string iterator, then my type for IT is a vector of type string iterator, right? C++ can figure it out here. And you can use auto for any sort of thing here. Like we can say, hey, auto for input is quotes here. Oh, can we not? Now we can't see in on it? Oh, shoot. Okay, maybe that one didn't work. My bad. Like auto number is 42. And C++ is like, oh, sure, number is an int. You don't have to tell me that because I know the thing on the right is an int. That sort of thing. So auto is becoming more and more common. It's just easier to type. For some of these really long, like this is actually more letters than int here to have to type this, but to not have to type vector of type string : iterator is kind of nice here. Right? So you'll see this a lot when you see more modern code. People do this a lot. Is that a question?
Yeah, so do you have to always dereference it every single time, or it's only that time?
So we're dereferencing it every time in the loop here. So we're increasing it by 1 every time, which says go to the next item, right? It's a size of this, go to the next item based on the size. It's the next item, go to this based on the size, go to this based on the size. And every time we're dereferencing it, because all it is, so if we don't dereference it, we just get the pointer notation. Oh yeah, it's not even letting us do it here. It's like, no, that doesn't work, right? It doesn't even know what to do with that, so.
Right, but if you're inside the loop, right?
Yep.
And you do the exact same thing that you did on line 42, do you have to do the star? Like if you just copy and paste from line 42 and then you just add it below it?
If I want to, like, what are you trying to do with it? Just print it out?
Yeah, print it out another time.
Yeah, so it's still a pointer here. So you still need to say, if you want the thing it's pointed at, we have to dereference it, right, to interact with it.
Okay.
Yep. Right, so we can see out. Now with this one, we should be able to, let's see. So if I take my dereference iterator, we should be able to assign to it here, test. Now let's see what we get here. Okay, so let's put a bunch of tests in, right? CIS 200. I guess the other numbers don't matter here, right? Sure, and quit. We get out tests, right? So you can assign to it while you're looping through, right? It's not a read-only here like these ones were, right? So just, you can assign to it the value pointed at the iterator, pointed by the iterator, right? Just like we could with our pointers, you can assign to, hey, the thing you're pointed at, change its value, right? We can do that, which is fun. You can also go backwards, right? You could start at the end and go until you hit the beginning, going minus, minus. You got some fun options here for doing however you want with iterators, right? Working through them here gets to be kind of fun. Now that we have that, iterators here, we can start removing items at a given location once we have the iterator here. Yeah, beginning and end, dereferencing it, incrementing it, modifying it. There we go. So C++ vector, remove item by index. Sure, let's see what we get here. How do we erase an element? We get our erase saying which one do you want to, so there's an erase function here. So if you looked at vectors, you're like, oh hey, classes dot erase. You're like, oh hey, I should be able to erase something here, right? Well, what do you have to erase? Well, it wants an iterator. And before we looked at these iterator things, you're probably like, I don't know what this is. I still barely understand what it is. That's okay. Don't worry about it. We're practicing, right? So what do you want to erase, right? So you can erase, hey, where are we erasing, right? So this is the thing that comes after the beginning, if you want, or you can go find, so we can loop through to get our iterator pointed at a given location here. So what we're going to do is we're going to ask them, hey, what class are you dropping, right? So we'll let me just comment this out because that's not really all that interesting here. So asking them, what class do you want to drop? Right, so see out, class do you want to drop, and an end line, and then we'll see in on input, right? So I have a class here. Now we're going to loop through, right? So I want to do this same iterator thing here again, but now I don't want to output. I want to say, hey, if my input is equal to whatever the iterator is pointing at here, right? Now we need to save this location so I can erase it, right? Let's just try and erase it. Let's see if we can erase it. So we'll say my classes dot erase given the iterator. Let's remove it. We found a match, right? And then maybe we just want to break the loop, right? I don't know if you want to erase all of them that match. Like if you register for CIS 200 twice by mistake, do you want to get rid of both of them or one of them? I don't know. We got some options here. Let's see if this one works for us here, right? So we've erased it, and then one more time, let's go through and print it all out. Again, we'll do the quick, easy one here for fun, and see if it erased. Okay, so we'll give it CIS 200, CIS 275, CIS 305, and then we'll quit here. That's probably enough for now, right? So here's the list, here's the list, here's the list. Which class do we want to drop? You gonna drop this one, 200? Oh, failed. Can't increment invalidated vector iterator. So when we go delete that and we erase it, it's no longer valid, right? Once you erase this one, this iterator, you know, we're garbage collecting, we're picking up, it's gone here. I can't go add one to it anymore because it's dead. It's gone, right? So we can't erase it directly here. So we have to wait to erase it until we're done here. So we don't want to erase it immediately, right? We need to go and store this thing here. So this is why it might be nice here to say, hey, let's go do this thing outside here. You don't technically need anything here. This part's optional. I don't know if you noticed that. I mean, technically all of it's optional. You just have an infinite loop, right? It's like a while true loop if you don't put anything in here. But all the parts are optional here. But we don't want to erase it. We want to say, now, I did another auto it to erase or something. I don't know. Erase. And then we can assign it here equals the iterator. Oh, no, I'm sorry. I can't use auto here then. Shoot. We'll just. I don't want to start at the beginning one. All right, I guess we can't auto it here. We'll just say vector of type string iterator. So once we find it here, we'll hang on to it. Our loop will finish, right? And then we can call classes.erase the it to erase. I feel bad. Iterator is just so obnoxious to type. That's okay. Iterator to erase. I'll be better. I always complain to you guys if you don't use good variable names, right? I should yell at myself. Now we should be able to erase it, right? Because we're not in the loop, so it's not going to break my loop here. Right? I guess we can really put this back in then, right? Because we don't need that. We can put it back in here. I don't know if that's any better or not. Let's give that a try. We get CIS 200, CIS 275, CIS 306, 305. I forget what it was here. Quit. Which one do you want to drop? We dropping CIS 200 again? You guys are bored? We'll drop it. Uh-oh. Still here in my list. Didn't erase.
You have to do that next.
The next should have been the next one. This is like a range here. I don't think we want the next one. Maybe we do. I don't know. Let's try it. Erase next of this one. I don't think that's what we want to do. Classes erase. I should have got rid of it here. 200, CS 275, CS 306, quit. CS 200, nothing. Are we? Oh. So remember when you set a pointer equal to another pointer? I kind of screwed it up because then they both point at the same thing. And then when this one increments, the next one increments, and the next one and then increments and then increments. You need to not do that here.
That's why I see I did CIS 200 twice.
So it never actually erased it here. So like if we put a breakpoint in over here and we run it, let's run it in debug mode. CS 200, CS 275, CS 306, quit. CS 200 drop. So we get here, and we've got our iterator to erase is pointed at this one here. Oh, it is pointed at that one. Okay, that's good. We did remember the right one. That's good. I thought it wouldn't. We've got our classes here, 200, 275, 306. Erase our iterator. Let's. Oh, what one did it remove? Oh, because we did next. It shouldn't have done next. Hang on, we didn't want next. That looks like it was going to work. What is going on here? Did I just miss it and it did work last time? I just thought it didn't. CS 275, CS 306, quit, CS 200. All right, So we got our iterator too. Oh, now it's null though. How did I type it wrong? I did. A CI 200. You guys, I need more coffee. I need more coffee. CIS 275, CIS 306, quit. CIS 200. There we go. All right, so now we got iterator to erase CIS 200. Where we're pointing at. We're going to call erase on our classes vector here, 200, 275, 306. We've erased 200, right? So now classes only has two things here. We print out that one, we print out that one, nothing left. It was working the whole time, friends. That's what I inputted here at this line. All right, should we be done? Time to just give up? All right, it was working. I'm just dumb because my output here. That's what I get for garbage output and input here. It works. Huzzah. So you can erase from a vector using an iterator. That's the whole story here. Very exciting. You'll remember me looking like an idiot for a long time now. Congratulations. Core memory unlocked. So that's our vectors, right? I think that's about all we did with these here then, right? We had a little more vector iterator. Reversing is not exciting. Resizing vectors, sure. The loop, modify, copy, or compare. So when you go assign a vector to another vector, does it have it in here? Yeah. It's the vector copy operation, right? So we're not going to get a pointer and another pointer pointed at the same thing because the fine folks who wrote our library in C++ said, hey, we're going to override the equals operator here. I'm not going to say they both point at the same thing. I'm going to go through and do a actual copy. We did our copy assignment operator, our assignment copy operator. Right? We wrote that for the project, or you are about to write it for the project. They did that for vector, right? So they know, okay, here's how we go and set, and I'm going to make copies of all the items here. So you can get a copy of your vector and have an actual copy here, which is nice. So that's kind of built in with it here. How do you feel about vectors? You love them? Much better than arrays, I promise. Right? You can't erase things in arrays without going through a whole bunch of headaches. Definitely, definitely. We'll get to some of those headaches though. Should we be so lucky here when we go do our own. So we're going to get to inheritance next week. So our next project will be on inheritance next week. So we'll go over the solution, we'll start inheritance, we'll start the project, and then containers and abstract data types. Lots of fun. We start getting into doing our own things and how these abstract data types work. It's a great library out there. We'll get into recursion. That'll be the project 2 will be on recursion. We'll get into templates. Once we've done templates, then we can start writing our own stuff here. We'll get into linked lists. We'll write our linked list based project. We'll take some time off for the midterm. Again, not meant to be hard. It's open book, open notes. I don't expect you to memorize anything, but you have to know enough to go find the answer, right? If you just don't ever know anything, like, it's probably unlikely someone who's not taken the class can show up and pass the midterm because they just won't even know what to Google, right? They might find some hits, that sort of thing, right? But know where to go find more information, right? Ideally, you're reading the iBooks as we go. It's a good reference. I'm trying to not give you exactly what they give you. That way you can see it my way, you can see the book's way, you can practice it in lab, you can practice it in your projects, right? You're going to repeat and repeat and repeat and repeat. Eventually you do something enough times it gets stuck in your head, or enough in your head that you can recall it, and have a little bit of success there. So we'll do the midterm, and then we'll come back, project 3, and we'll start our final project, hopefully on the 24th. We got a whole month to work on it here. We'll do some stacks and queues. So we'll use some stacks and queues, I think, in the final project. If I remember right, I'm not that far ahead. I'm lucky to be like the same day, maybe looking at the next day. I know what I'm doing tomorrow because we're playing Dungeons and Dragons. That I've got in my head, right? And then searching and sorting, we'll get into some basics of searching and sorting. It won't take the whole time, so we'll have more time for the group project at the end of each class. Streams and ethics won't take the whole time. We'll have some more time at the end of each class for those. And then the last week is just group project work time here. So I think because of the way this falls out, we'll probably still have lab, an ethics lab, but it'll take like 10 minutes. And most of the lab time you can use for your group project that night as well. And ideally, you're done by the 16th. Right? If you can get done before finals week, you can focus on your other finals that people like to see if you can memorize crap. I don't care if you can memorize anything. Right? That's not the goal. I care if you can write working code. That's my ultimate goal. You end up the class, you can write working code. It doesn't even have to be pretty code, to be honest. Like, working is the baseline. Pretty is, that's ideal, but we get to working here. And then our final exam slot will present our group projects, right? Yeah.
How many people are in
2. Yeah, pairs. Like, it's not really enough work at this point. If I gave you something that large, it would just be a giant headache. Yeah.
Would any of the projects that we do in this class in the lab be good enough to put on your resume?
No.
I feel like it's really help.
No, so.
I'm gonna tweak it a lot, but use the lab that we do.
So stuff that's interesting on a resume is something you've put time, energy, and effort into that's not something you do in every class.
Okay.
Like, every time I got a resume from a fresh graduate, they're like, I did the traveling salesman problem. I'm like, that's garbage. Everybody does the traveling sales problem in 350. I don't care. Like, I know you took the class. Why are you telling, like, this is not an interesting thing? So if you're going above and beyond doing something interesting with the project, that's a good thing to put on your resume because it's something you can talk about that's unique to you that, the 1,000 people who got their degree didn't all do, that sort of thing. So anything like that'll be fun. Like, your senior design project is designed for that. Like, here's a unique project that you guys put 2,000 hours into to get off the ground across 2 semesters. Like, that's a really cool thing. You can talk about your stuff for that. Like, even things you do in 350 are just boring because everybody does them in 350, right? It's basically standard across all the, maybe not all the schools, but like everybody does these puzzles, that sort of thing. Yeah, I mean, if you want to have a working Connect 4 game, maybe. It's not the most interesting thing here, but maybe with Connect 4, be like, hey, look, I built a Connect 4 game and you can play it. Yeah, I don't know how many people do that one, but you could talk about it. But again, I wouldn't have hired someone because they wrote Connect 4. Right? If you go publish an app on your own that does Connect 4, and hey, I've taken it across the finish line to get an app published, that's kind of cool. I don't know if I mentioned, we hired a guy, he had published an app for guitar tuning. Like, his had nothing to do with his background. Like, he was a programmer, but like he wanted to figure out how to do all this stuff. He never worked with mobile. His company didn't do mobile, and he just wanted to go do it on his own. So it showed some initiative that he's able to go across. It wasn't an amazing app or anything like that, but it was cool to see he was curious enough to go do the whole process, that sort of thing. So, all right, awesome. Well, you folks take care. I will see you Tuesday then.